Okay, in this video we're going to talk about drawing skeletal structures or line bond structures or whatever you want to call them. What I mean by that is using the shorthand writing for CH bonds, which makes drawing structures a gazillion times easier. Okay. What I have is, before I started this video, I drew out this rather long and painful looking molecule. And if we were just to count up, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 carbons in that longest carbon chain there with an alcohol on the end, and then we've got bits coming off several different carbons. Now, if you were to have that in a reaction, you have to draw that out 4 times. Frankly, that'd be a pain in the butt. So let's come up with a shorthand way of doing that. Well, the first thing we're going to do is draw out the longest carbon chain, and we said that was 11 carbons. And so all we're doing here is drawing out a zigzag, like so, where the start point of the line is a carbon, and where the slope of the line changes is also a carbon. So you can imagine it either at the peak of a hill or the bottom of a trough. That's where there is a carbon. Now, how many carbons do we have here? Well, we have 2, 4, 6, 8, 10, 11. Now let's just check that again. 2, 4, 6, 8, 10, 11. Okay, so we have the right number of carbons, and let me just count these up again to be sure. 1, 2, 3, 4. Tell you what, let me number them as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm so good. All right. Okay, 11. There we go. Now, you can already see our longest carbon chain in this shorthand form is a lot shorter than it was before. Now, let's just talk about a couple of things. Whenever you have a CH3 in a molecule like this, because that carbon is connected to 3 hydrogens and only 1 other carbon, that CH3 is always going to be the end point of a line in a structure like this. So when I go to carbon number 2 here, which is this one, can you see how many methyl groups I'm going to put on that carbon? Well, there's this one here, and there's also this one. And this is where I want us to try and be a little bit particular about how we draw these on. I'm not going to invoke any stereochemistry yet, but if the 2 bonds here point up, so if you imagine you're looking at this carbon, this bond points up to meet it, this bond points up to meet it. So if you're meeting at a peak here, then you'll draw your 2 methyl groups also coming up like this. Okay, so if the 2 bonds of the carbon meet pointing up, then the groups coming off it also point up. So that's carbon 2. Now when we go to, for example, carbon 3 here, see, that's a CH2, which means a carbon with a carbon either side of it. And so this is a CH2. So whenever you see the midpoint of a line where the slope changes and there's nothing else going on, that's a CH2. So the end point of a line is a CH3. So we've got 1, 2, 3 CH3s here. And the midpoint of 2 lines is a CH2. Okay, and you can see carbon number 4 is the same as carbon number 3. Now when we get to carbon number 5, notice this looks different, because what do we have coming off carbon number 5? Well, we have an ethyl group and we have a propyl group, 3 carbons, 2 carbons. Now on carbon number 5, the 2 bonds meeting up to form carbon 5 point down. So therefore I'm going to show my 2 groups pointing down. It doesn't matter if I show the ethyl on the left or on the right. So I'm going to say here's my ethyl, and then here is my propyl. Something like that. It doesn't have to be perfect, but something like that will do just fine. Now carbon 6, 7, and 8 are like 3 and 4. They are CH2 groups. All right. They're actually called methylene groups. CH3 is a methyl group. CH2 is methylene. Now when we get to carbon number 9, you can see there is a change again because we don't have a CH2 here. If this is carbon number 9 here, we have one methyl group coming off there, and these two lines meet pointing down, so therefore the methyl group is also down. And then we get to number 11, and it's a CH2. Hang on a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this is carbon number 11, and what is coming off this carbon number 11? Well, there's the two hydrogens, but there's also the oxygen, and you always want to show the bond to that heteroatom, even though you don't show the carbons. And whenever you have hydrogens on those heteroatoms, you always show those. So you can see, all I'm not showing is the carbons and the hydrogens on those carbons. If hydrogen is on anything else, then you show it. So what I've done here is, this is the shorthand form down here of the big nasty looking structure that we had up there. And let's just clarify something, okay? When you have the end point of a line, what did we say that was? We said the end point of a line was a CH3, a methyl group. Now, can you see how many endpoints of lines we have in this structure? Well, we have 3 that I've circled here, but I also have methyl here. It doesn't matter, this is a propyl, there's still a methyl group on the end. So I have 6 endpoints of lines in this molecule. All right. And then we can look at, so if that's methyl, then the methylene group is where 2 lines meet. And if I put a green circle around each of these, you'll see how many of these we have too. And I just want you to be able to notice the difference between CH2 and CH3, because if you can get that now, recognizing the difference will be so much easier for you later on. And notice now there are only 3 carbons left. Actually, I need to put CH2 there, CH2 there, and CH2 there. There are only 3 carbons left I haven't put circles around yet, and it's that one, this one, and this one. Now we've talked about CH3. We've mentioned CH2. So CH3 is the end point of a line. Okay. CH2 is the midpoint of 2 lines. One other option is, the next one down would be CH. So if CH2 is a carbon that has 2 bonds to carbon and 2 bonds to hydrogen that you don't see, a CH would therefore make sense to be a carbon with 1 bond to hydrogen, so therefore 3 bonds to carbon. Now, out of the other 3 carbons left, how many CHs do you see? Well, I hope everybody can agree there's definitely a CH here. But is that a CH? Or is that a CH? Can you guys see what the difference is? The number of bonds to this carbon is 3. The number of bonds to this carbon is not 3, and neither is this. So therefore that means, hang on a minute, I'll just say the CH there is black. So that means then, if originally I had a CH3, then a CH2, then a CH, when you have 4 lines into converting, that means you actually just have a carbon with no hydrogens on it. In other words, bonds to 4 other atoms, usually carbons. And so how many of those do we have? We have this one, and we have this one. So it's important for you to be able to recognize between the different types of carbons in a skeletal structure like this, and to be able to go from here down to here. And to be able to go back the other way. All right? So if I was to say, for example, if we just go onto another sheet here, if I was to say something like this, let's put that here. Okay. This is something called a ketone. there is an oxygen that's doubly bonded to the carbon. Now notice I'm not showing the carbon, but I show the oxygen doubly bonded to it. If we just look for our longest carbon chain, we have 1, 2, 3, 4, 5, 6, 7. So that means I'm going to have 7 carbons in my longest carbon chain. But what I'm going to try and do right now is convert this skeletal structure into a structure like we had here, the one you don't want to be drawing too much of, unless you really like drawing things like that. So we're going to start off here, and you pretty much always want to start off with a CH3. And then we want to go from that CH3 to the next carbon, which is going to be this one. And this is where we have to be careful, because coming off this carbon is another carbon here. In fact, we can draw all our 7 carbons in a row. So how about we just do that? We've got 5, 6, and 7. Now, coming off this second carbon, what do I have coming off there? And bear in mind, in this structure, we are showing everything. Well, what's this going up here? Well, that's a CH3. So we have to show that. So that means what else is here? What's in this 4th position? Well, that's a hydrogen. Now we go on to carbon number 3. There's another methyl group here. It doesn't matter whether you show this one up or down. There's no stereochemistry here to speak of. For the sake of clarity, I'm just going to show it down, which means here there is another hydrogen, and then on that next carbon there's another methyl group. Maybe I should have made my substituents different. Oh well. And then coming off this carbon, what do I have coming off this carbon? Do I have any methyl groups coming off there? Well, the answer there is no. So I must have 2 hydrogens. That's one of my CH2s. Now coming off here, this is my ketone group. So I have that doubly bonded to oxygen. Notice my carbon still keeps its 4 bonds there. And then we have the end of a line here, just like we have here, 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 and here, which means this must be a CH3. Now, if I was being really particular about this, I'd be writing out each of the CH3s, but, well, I'm lazy. Okay, that's a little bit about drawing shorthand